Now I'll show you how to train custom RF-DETR object detection models. There will be 4 main steps: installation guide, dataset preparation, training, and testing the model. So if you start with installation guide, you have 2 options. You can use servers like Kaggle or Google Colab if you don't want to spend time on driver installation and other dependencies. But if you want to train your models locally, you have to create GPU-supported PyTorch environments. It's not that complex. I explained everything step by step here. First, you need to create a conda environment. Then you need to install PyTorch with GPU support. And you can directly use this line, but if you got any error, you can follow this article. I explained everything here, including Anaconda setup and other things. You see here. So after that, you have to clone this RF-DETR repository, this one, and you need to install dependencies. You can directly copy these 3. And after that, you can check if everything is okay by, copy the cell. And by the way, I already, cloned this repository and created my environment. Now I will test it. I create new notebook and name it as YouTube. So you see here my environment, RF-DETR. So I'll run this. This might take some time. Using device CUDA, this means everything is okay on GPU side, and we have few warnings, but these are not that important. We can still continue. So the next step is dataset preparation. I randomly choose dataset from RoboFlow, but there is one important point, and that is your dataset must be in CocoJSON format. If it is not, for example, if it's in YOLO format, you have to convert it to CocoJSON format. This is important. And this format is is not that complex. There's one JSON file for training, one JSON file for validation. It goes like this. And this is my dataset. I randomly choose. It's not that important. So if you want to use same dataset, you can click this download dataset, and after that you can choose CocoJSON formats. Or if you want any other dataset, there's only one rule, as I said before, CocoJSON formats. And let me show you this actually here. You see here my datasets. So for example, under this train folder, there's one JSON file that contains annotations. Yeah, you see here, and there are training images. And this is same for validation. Let me show you that. Yeah, you see image, and one annotation file. You can name it like this, annotations.coco.json. And by the way, this dataset is about, detection of basketball player, referee, and ball. You see player, ball, and let me find one referee. Yes, you see here referee. So let me continue. So there's a lot of pre-trained models. Depending on your GPU, you can go with medium, large, nano, small, it's up to you. But my GPU is not that powerful. I have like 6 GB VRAM. So I will stick with RF-DETR Nano. And you can find all of these models, inside this repository. Yeah, you see here. You can see like resolution, parameters, and some, precision values. So depending on your dataset and GPU, you can choose any of these. And let me copy this cell for training. Yeah, you see here RF-DETR Nano, device CUDA. This means that training will be done on GPU. And we have few parameters. This is dataset path. We need to change this to like what? Dataset basketball. Okay, let me rename. Nice. You can change this epoch number. Let me do like 30. So depending on your dataset and other parameters, you can adjust these. Depending on your VRAM, you can increase this page size, but I like 6 GB VRAM, so I will stick with 2. So you can change precision. It's up to you. And this is output folder name. Let's rename it as YouTube results. And this is run name. You don't have to change this. So I'll start training. So this will take some time, like 2, 3, 4, 5 hours. I don't know. So we will wait. And after training is finished, I will continue. Okay, now training is finished. You can see the metrics. And now I will test the model. I will use this code block. So here we are basically, first we'll load our model, trained model. You see here, this is output. Let me show the results. So here there's like trained models and metrics. Yeah, you can analyze these values and you can change your training configuration. You can train again, but I'm not gonna do that because it's not the purpose of this video. So here we are loading our trained model. And here we have like this test image, but I will choose it randomly from, where is that? Yes, here, test. Yeah, for example, this one. Let's choose this, copy path. Okay, you can change this threshold value. And here we have like labels. And let me run this cell. I will use matplotlib for displaying the result, but you can use OpenCV or any other thing. It's up to you. So we will use this box annotator and label annotator for displaying this bounding box and label information. So here's the result. You see player, referee. Okay, cool. Yeah, you can use any other test image. It's up to you. You can run this model on videos or live streams as well. So let me check if there's else. Yeah, okay, that's it for this video. Thanks for watching. See you soon.